So once again, I would like to thank you from all of our team that you have had so much of patience and you cooperated with us. And I hope that now the video quality as well as the audio quality is better. So let's begin with the session now. And this session is about 40 algorithms in 40 minutes. And I would like to tell you that the audience is from different background and different level. So we would try to keep the things simple and we would try to make it as understandable as possible. So let's begin with the session. And let's start with algorithms as we did in the morning. I will keep you running through some running presentations as well. So let's basically start algorithms. Okay. In order to make the session interactive, you can keep on writing in the chat box so that I can get notified that you are along with me. You are running along with me. Okay. So let's begin. What is algorithm? I believe everybody knows that step by step execution. Okay, so this is the phrase that everybody knows. Step by step execution. Okay, of what? Of a process. Step by step execution of a process. This is called as an algorithm. Okay, and for what can we write an algorithm? For what purpose? Morning, I gave an example. Let's say you want to prepare a cup of tea. Okay, so if you want to prepare a cup of tea, you will have to follow a process. And this particular process is equal to an algorithm. So somebody who is very new and has never basically listened about or heard about or read about an algorithm. So understand, an algorithm is step-by-step execution of a process. Example, preparation of a tea. You need to follow a process that is an algorithm. If you want to collect the rainwater, for that again, okay, what do we call it as? Rain water harvesting, right? So if you want to collect rainwater, again what you will have to do, you will have to basically follow a certain process. That process could be, you will have to take maybe a bucket, you will have to take some pipes, and you will have to adjust those pipes such that whatever water is being collected, that should get into the bucket. So again, there is a process to be followed. Okay, so again, this process is called as an algorithm. So I hope now the concept algorithm is clear. Okay, an algorithm makes it very simple for us to basically achieve the objective which we have. Now let's go back to the presentation. We will have in two levels: the basic level, that is searching and sorting, and we will have advanced level, that is data science. Okay, so let's begin with the basic level of algorithms. So we have multiple types of searching algorithms. Few of them I have listed here. You can read it out here: linear search, binary search, jump search, interpolation, exponential, sublist, Fibonacci. So many types I have written here, and this is not the end of the list. There are so many types. Okay, if you want for a specific type, you can write us in the comment box, and we will surely make a note of it, and we'll come back with a video for that particular algorithm which you want. Let's begin with the linear search. What does the term linear mean? Linear means, think of a line. Okay, maybe you can think of a number line. Okay, so how does a number line come into your mind? Okay, so let's say this is a number line. Okay, I have a line here, and let me just make it bold so that it's visible. So you can see that we have a line here, and let's say if I start writing numbers, okay, 1, 2, 3, okay, and start putting these numbers across this line. Okay, 4, 5, 6, 7. Okay, it'll keep on happening. It'll keep on. Okay, I can keep on increasing the number of. Okay, so what is happening in this particular number line? The numbers are basically increasing from left to right. 1 2 3 4 5. Okay, and now if you want to make a search, okay, so let's say I have some elements. Okay, I have some elements. I'm basically drawing some elements here, so you can see that I have some elements into this particular table. The elements are 21, 45, 23, and 1. So I have 4 elements in this particular list. Let me call it as list. So these 4 elements, if you see, I have to find element 45. Okay, so which element do I need to find? 45 element I need to find. So I will call this as a key. Okay, so this 45 will be called as key. So you can always remember, whenever I'll call something as key, that means that is the term to be found out in the that particular given list. Okay, now what will happen in this case? What will happen? I will search element by element starting from the first point. Okay, so this is my first point, and let me write here as this is my first element. Similar way, I have this as second element, right? This as third, this as fourth. Okay, so what does linear search means? I'm taking more time on linear search because if linear search is clear, then rest of the searches are, you'll be easily able to understand them. Okay, so what is happening in the linear search? First element is 21, second element is 45, third element is 23, fourth element is 1. Okay, so 4 elements are there. Now first position is 21, second is 45, third is 23, fourth is 1. 45 is the key. Key is basically the element which we need to find. And now I am starting with the first element. Okay, so I'm matching my key with the first element. 45 I'm matching with 21. Is it matching? No. So I will move on to the next element. The next element is 45. Is it matching with the key? Yes, it is matching. So search is finished. This is called as linear search. Okay, why? Because like in a number line, from 1 to 2, 2 to 3, 3 to 4. Okay, that is how we are basically moving from first element, second element, third element, and fourth element. This 1 2 3 4 5. Okay, this is called as indexing. Okay, so this is again important part. So those who have studied this thing, they must be very clear with this concept. Okay, those who are new to this, so for them you need to understand these are called as indexes, or the concept is called as indexing. Okay, so if I say what is at the fourth index, as per the representation I have done, the fourth index value is 1. Okay, all right, now let us move ahead. This is called as linear search. Then we have another search type, and the diagram will depict you that how does it work. Another search type is binary search. Binary itself means 2. Okay, the meaning of binary is 2. Okay, so if the binary meaning is 2, then the concept basically runs like the whole of your array. Okay, array means your complete list. So whole of your array is divided into 2 parts. Okay, and then what do we do? Again, the sub parts are divided into 2 more parts. Okay, so let's basically have it pictorially. Okay, have it pictorially here. So here you can see that we have the list 0 4 7 10, and 14 is basically, you can see, is the center element. Okay, so the whole of the list is divided into 2 parts. Okay, the whole of the element is divided into 2 parts. Okay, and after that what we are doing, we are searching for the element 47. Okay, so 47 is the element we are searching. Once you divide it, okay, once again let us see. So 14 is the center of the element. It is in a sorted manner. Okay, remember, it is in a sorted manner, and center is 14. So 47 is greater than center, so we will discard all the left hand side elements. We are discarding all the left hand side elements. Okay, and then again we are finding out the center, and from the center we are again discarding the left hand side because 45 is smaller than 47. Okay, so this is how you can see that in case of linear search, it is taking more time because it is sequentially searching one by one each element. But In case of binary search, it will take less time. I got a comment to basically include the time complexity and the space complexity. So I assure you, I will give you in the next video, because it was very less time to include for each and every algorithm. So I have not included that part. So I'll give you a separate session on time complexity and space complexity separately. But here, overall, you can see that binary search may perform better as compared to linear search, or in most of the cases, it will perform better. Jump search, okay, it is also known as block search. Okay, jump search is also known as block search. So this particular type of search is, as the name you can read, block. It works for a group. Okay, it works for a block, and it just make the search in that particular block, and then it creates another block, and it goes on to search the particular element in that particular block. So this is how basically the jump search works. Okay, so create a block will contain, let's say, 3 elements, 4 elements, 5 elements, and make your search there. Okay, so that is how it works. Let's move on to another type of search algorithm, that is interpolation search algorithm. This interpolation search algorithm, if you see, so the purpose of this interpolation search algorithm, you can basically read the definition. Okay, what does this mean? So interpolation means that insertion of something of different nature into something else. Okay, so interpolation means insertion of something of different nature into something else. Okay, let's say two people are interacting, and there's a basically a truck passes by and making some kind of noise. So there was a discussion, a soft discussion was taking place, but immediately there was a truck passing by. Okay, so this truck passing by is interpolation. Okay, so what happens in interpolation? Okay, so yes, interpolation search algorithm, it is used for searching for a key in an array that has been ordered by numerical values assigned to the keys. Okay, so key again is that particular element which we want to search. Okay, and this algorithm is an improved version of binary search, so it works like a binary search only. Okay, but what is additional here? The additional thing is that there has been one ordering done with numerical values which is assigned to the keys. Okay, and the condition for interpolation search is that the data collection should be in sorted form and equally distributed. Okay, so this is the condition in case of interpolation search. Next, we have exponential search. The word exponential, if you see, so it immediately basically gives something in the mind, that exponential means that something to the power of something. Okay, 2 raised to 3, 4 raised to 5. Okay, this search is also called as galloping search, doubling search, Struzik search. Okay, so there are multiple names for this, and you can see in the diagram also. Okay, it depicts that what kind of nature this search may be having. Okay, the primary idea here is to determine a range. Okay, range that the target value resides in, and perform a binary search within the range. Okay, so if you understand, what we are doing is we are performing binary search only, but how are we doing that? Okay, how do we do that? We do it basically by deciding a range, and that range will be deciding by some exponential function. Here you can see that the mechanism is used to find the range where the search key may present. There is a lower bound and there is a upper bound. So the upper and lower bound, okay, will create a range, and we will find the element inside that range. But if we don't find, if the element is not found within that range, what we will do, we will basically shift this upper and lower bound to the next segment. Okay, and that won't be overlapping. So this is basically how the exponential search works. There is another type of search which is called as sublist search. This sublist search, if you see, this is search a linked list another in another list. Okay, here you can see one example. We have a list, and the list contains 3 elements. The 3 elements are 3, 1 and 2. So these are the 3 elements in a list. We have a second list here, and this second list, if you see, In the second list we have multiple elements, and now here we are trying to identify the first list, is it present in the second list? So that type of search is basically called as sub list search, because we have a bigger list of items, and in that bigger list we are trying to find out a smaller list which we have. Okay, so this is called as sub list search. Then there is a concept of Fibonacci. Okay, if you have heard this concept of Fibonacci, then you will be easily able to understand that. First, let me take you to what is exactly Fibonacci. Here you can see the numbers. Okay, you are able to see the numbers here: 0, 1, 1, 2, 3, 5, 8. Okay, so what kind of relation is there in these numbers? The relation is explained in the below term. This is the relation explained. Let me explain you into a different presentation. Okay, let me explain you in a different presentation. So here, let's see what is a Fibonacci. In Fibonacci, you can see in the presentation the first element is 0 and the second element we have is 1. So these are the two elements in the Fibonacci we have. We have to find out the third element now. Okay, so two elements we have, third element we have to find out. In order to find the third element, we actually need to sum the first two elements, and that will give us the third element, and 0 plus 1 becomes 1 only. So in this particular series, we will have the third element as 1. Now, what is the next element? Now we have to add 1 and 1, because these are the latest two elements. It will give us 2. So the next element here would be 2. So the next element is 2 here. Okay, now let's move ahead. Okay, let's move ahead. Now what will be the next element? Okay, if you see, this is also an algorithm. Fibonacci itself is an algorithm. Okay, now the next one is 1 plus 2. Why? Because 1 and 2 are the latest two elements. It will become 3. Okay, and it will keep on happening. Okay, it will keep on happening, and I believe now you'll be able to generate Fibonacci numbers. Okay, so next element is 3. Okay, next would be 2 plus 3, that is 5. Next would be 5 plus 3, that will be 8. Okay, so this is how the Fibonacci series will keep on increasing. So we will make use of this series in order to make a search. Okay, so what is happening here? You can see that Fibonacci search is an efficient search algorithm based on divide and conquer principle that can find an element in a given sorted array with the help of Fibonacci series. Okay, so again it's a divide and conquer. Okay, so if you see most of the algorithms, okay, binary also it is dividing. Okay, it is dividing into two parts. Always it is dividing into two parts. Okay, so Fibonacci search is also based on the same thing. Okay, we have to divide the data, but here for dividing the data, we will be making use of Fibonacci series. Okay, and I have shown you that how the Fibonacci series works. All right. Now, like other searches, okay, like other searches like binary search, they also work on the same principle of splitting. We are splitting, right? So splitting the search space. Search space is nothing but your numbers. Okay, 1, 2, 3, 4, whatever number of items you have, that is called as search space. So all algorithms, they are working on the concept of splitting the search algorithms. Okay, smaller space. But what makes Fibonacci search different is that it divides the array into unequal parts. Okay, so most of the algorithms they have, okay, like block search, the jump search, so it has got a block. It is also dividing the search space. Okay, if you see, it is also dividing the search space. Okay, so here the search space is divided into unequal parts because Fibonacci numbers are different. Okay, they're having different. Okay, so this okay just involves simple operations of addition and subtraction, which ultimately can help us in reducing the workload of computing machine. Okay, so that is a benefit of Fibonacci search, you can say. Okay, that's the benefit we get from Fibonacci search. Moving on to the next part, that is sorting algorithms. Few of the sorting algorithms I have mentioned here: selection sort, bubble sort, insertion sort, merge sort, quick sort. Okay, sorting, you know what is sorting. Let's basically have a very simple example of sorting. Okay, those who are watching the algorithm sessions for the first time, okay, so for them let's have a very quick example of what is sorting. Okay, so we have elements. Okay, and what elements do we have? We have elements 3, and after that we have 1, and after that we have 2. Okay, so these 3 elements we have, and now what do we want? We want to sort them. Okay, what is sorting? So sorting is ultimately we want them to be in a proper format. And what will be the proper format? The proper format would be 1 and then 2, and after that we should get 3. So this is the proper format we should have. Okay, so this is what is the objective. Okay, now let's move ahead. Okay, let's move ahead. How will you do this? Understand one thing. There's an approach. Like as a human being, if you see, you don't know, your brain just worked and you sorted the numbers, but it's the same thing you want machine to perform. Machine has to do it step by step. Okay, so again it's an algorithm. Okay, what machine will do? Okay, let's take one example. Machine will compare. Okay, machine will compare two elements at a time. Okay, so the two elements are your 3 and 1. These are the two elements machine is going to compare. Okay, so once machine is going to compare these two elements, okay, so 1 and 2 elements at that particular time, okay, at that particular time it will see that 3 is greater and 1 is smaller. So I should make a swap. What is swap? 1 will go in the place of 3 and 3 will go in the place of 1. Okay, so this is again an algorithm. What we did, we basically picked up first and second element and we compared them, and we found that first element is larger and second element is smaller, and we swapped them. Okay, as soon as we swapped them, okay, then we got a list. Okay, like 1 3 and so we got a list 1 and 3 and 2. So this is the kind of list we have got. Okay, fine. All right, so this is the kind of list we have got. Still it is not sorted. Okay, it is not completely sorted. So now what we will do in this particular list, again we will perform comparison of two elements, and this time the comparison is of element 3 and 2. Again we find that 3 is larger than 2, so we will swap them again, and once we will swap them, we will get the perfect and final sorted array. So 1 comma 2 comma 3. So this is the sorted array we will get. Okay, so this is how basically the sorting takes place. Okay, a very simple step by step I explained you. Okay, and now there are different algorithms for doing this sorting. Okay, now here you see that one process is called as selection sort. Okay, so here you can always remember whatever is the name of the algorithm, that name itself plays a important role in the particular algorithm. Selection. Okay, so here basically we will create two lists. Okay, one list is already given and a new list we will create. The already given list is unsorted, it is not sorted, and a list which we will create, it will always be sorted. Okay, let us see it by example. Here you can see that we have some elements, and these elements we will sort. We will find the minimum element, and finding the minimum element, we will keep it in the sorted array. 1 is the minimum element found, and it is kept into the sorted array. Okay, so this is how this selection sort works. Now we will keep on exploring 2 4 6 5 3. 2 is the minimum, 2 has sent to the sorted array. Now 4 6 5 3, 3 is the minimum, 3 is sent to the sorted array. So this is how basically it works. This is selection sort. Okay, there are slight differences between all the different algorithms. Let us basically see what is the difference. Okay, this is selection sort, right? Now bubble. Okay, bubble sort, it is one of the simplest sorting algorithm. It compares the two adjacent elements, and after comparing it just swaps. So 5 6, 5 was smaller, it swapped. 6 3, 6 is greater, swapped. Okay, 6 1, again 6 is greater than 1, it will swap. Okay, and in the next one, if you see 6 and 8, 6 is smaller, it won't do anything, it will simply move ahead. 8 7, 8 is greater. Okay, let's swap. So I believe you got the idea. So bubble sort works on each first two element, second two elements, third two elements. It will keep on basically comparing, okay, two pairs, and it will keep on iterating until and unless there is no requirement of swapping. Okay, this is basically the functionality of bubble sort. Then let's see how the insertion sort works. Okay, it is simple. It is like, playing the cards. Okay, so how we basically arrange a card. So here we pick up, okay, one element and we put it into right position. We pick up the next element, we put it into right position. We pick up the third element, we put it into right position. Okay, so are you getting what we are doing? We are picking up one and we are putting it into right position. Okay, irrespective of how many swaps are required, how many comparisons are required, we'll put it in the right position. Okay, this is called as insertion. So putting it into the right position means we are inserting it into the right location, inserting it into the right position. Okay, that is called as insertion. Okay, so this is insertion sort. Let's move ahead. Okay, let's move ahead and have a look at merge sort. Okay, merge means mixing up, merging up. Just look at the diagram. Okay, look at the diagram. What is happening? We had a list and we are dividing the list into pieces. Further, we are dividing the list into multiple pieces. Okay, so let me go back and come again. Okay, yes, just observe the complete list is there, two parts. Again, the two parts are subdivided. Okay, again the parts are subdivided until and unless we are getting the single elements of the list. And now first two will be compared and sorted, then second two will be compared and sorted. Okay, similar way third two will be compared and sorted. Okay, so this is how this also falls under divide and conquer algorithm. Okay, we keep on dividing and then we start merging. Okay, similar to merge sort, we have another algorithm called as quick sort. Okay, so diagram depicts that first it will split up everything, it will divide, and then it will start sorting. Okay, let's see the quick sort. Okay, so here you can see quick sort. It is again like merge sort. The only difference is here we have a pivot. Okay, so we have a pivot and we don't divide like in merge sort, we just start dividing. Okay, you can say from the middle of the list, from the middle of the center of the array, we start dividing and then we start the merge process. But in this case quick sort, how we do is we basically we decide a pivot, and that pivot is basically can be the first element, that pivot can be last element, that pivot can be any random element, that pivot can be median also. Okay, so anything could be pivot. Using that pivot, we basically then start the divide and conquer strategy. Okay, so here you can see that 3 is selected as pivot, and then basically we have started the merging part. Okay, so choosing 3 as pivot. Okay, so this is how we have to select a pivot and then partition. Okay, so this is how the quick sort is different from merge sort. Let's move ahead. Heap sort. Heap, if you know, okay, heap is called as, okay, something like this. Okay, so something is basically piled up or kept over each other. Okay, that is called as heap sort. Okay, so there is a data structure which is called as heap data structure. Okay, it is present in almost all the programming languages. Okay, so here basically heap data structure is used in order to sort the algorithm. Internal algorithm which is used is selection sort. Okay, so that we have discussed that in selection sort what we are doing. Okay, we are finding the maximum element first and placing the maximum element at the end. Okay, or vice versa we can also do right. We can find the minimum element first and we can keep the minimum element at the first position. Okay, so here what we are doing, finding the maximum element first and putting the maximum element at the end. Okay, but we are using a heap data structure, okay, in order to make the sorting. Okay, so 8 is sorted. Now we will find out the next maximum element. Okay, so we have found out next maximum element. Okay, and it is also iterative process. If it is not sorted, again we will create a heap. Okay, and then we will sort, again we will create. So it is a iterative process. Okay, fine, let us move ahead now. This is shell sort. Okay, so shell sort is variation of insertion sort. Okay, so you can see that the primary sorts are same. Okay, but basically there is a little bit difference in the sorting algorithms as we move ahead. So in insertion sort we move elements only one position ahead. Okay, so the difference, understand the difference. In an insertion sort we move elements only one position ahead. Okay, but when an element has to be moved far, many movements are involved. Okay, so the idea of shell sort is to allow exchange of far items. Okay, exchange means swapping of far items. So that is something needs to be allowed in case of shell sort. This is the difference. Okay, so what we do, we decide that first how many items should get sorted. That is something we start to do. Okay, that is something we start to do. And then the let's say we select 3 items first. Okay, then we will reduce the length of 3 to 2. Then we will reduce. Okay, so 2 is the minimum, right? So we basically try to sort up to h or up to n numbers, and then basically we keep on reducing the numbers in order to sort the algorithm. Okay, this is what happens in shell sort. One more interesting algorithm is Radix Sort. Whatever algorithms we have discussed till now, this Radix Sort is basically a little bit different. Okay, Radix Sort is a bit different. How is it different? Okay, how this algorithm is different? This algorithm is different because each and every algorithm which we have seen till now, okay, each and every algorithm which we have seen till now, they are basically based on, okay, they are based on some kind of comparison. Okay, here you see whatever algorithm they are comparing, okay, first and second element they are comparing. But Radix Sort, it is not comparison based. This is different. Okay, so why this is different? Okay, because it basically works on, it works on let me explain you here. Okay, how does it work, the Radix Sort? Yes, so here I'm taking a number. Okay, so the first number is 8, the second number is 80, and the third number is 800. Okay, so here if you see that in the first one, if you see, we have only, okay, let's basically categorize the data into ones, tens, and hundreds. So this is your data, and let's categorize this into, okay, one place, 10th place, and 100th place. Okay, so here in this one we have only one value which will come here. There is no 10th place, there is no 100th. Okay, in 80 here it will come 0. Okay, and in the 10th place it will come 8. Here in 800 it will come 0 here, 0 again here, and 8 here. Okay, so if you see the first, okay, is 8, second is 80, so the first place is basically 0 here. Here if you see the 10th place is 0, first place is also 0, and the 100th place is 8. So Radix Sort basically works on this principle. Okay, works on the place value which your number is having, and iteratively is basically sorts for ones, it sorts for tens, it sorts for hundreds, and whatever is the maximum number you have, that particular position, okay, 1000, 10,000, whatever is there, okay, that will be taken, and iteratively it will sort for ones, then tens, then hundreds, and this will eventually give you a sorted array. Okay, and sorted. This is Radix Sort. Okay, how does Radix Sort works? Okay, let's move ahead now. Okay, so these were the basic algorithms. If somebody is very much new here, maybe from 12th standard or from 11th standard, or maybe junior to them, or somebody is doing the diploma in computer IT or electronics, okay, where you have programming, or somebody is in first year or second year, so all these algorithms, okay, will come to you, okay, or you might have read them. Okay, other people who have already, passed out, who are already in third, fourth year, they have gone through these algorithms, and people who are working professionals, obviously they already have gone through these algorithms. Okay, now let us discuss advanced algorithms. Okay, advanced section, I have mentioned it as data science algorithms. Here majorly I'll classify them supervised, unsupervised concept. Okay, and that I will explain to you. Okay, so let's start now. Okay, so what does this word mean, supervised? Okay, so just can you please, those who already know something about supervised algorithms, can you please write in the chat box what exactly means supervised? Okay, so that I can read it out, and can gain some understanding that how many people actually know that what does this word mean, supervised. Okay, in terms of the algorithms which we are going to discuss. Okay, please quickly just write in chat so that I can get to know that what is the concept of the supervised algorithms, Okay, yes, quickly let's have some answers on the chat box. Yes, I'm waiting for the answers. Okay, so yeah, Vivek says that label already given. Okay, yeah, that's true. Yeah, label already given. Okay, yeah, label data. Avi says yes, label data. Correct. Yeah. So let me in a very simple way, let me put it across you. Okay. So here I'm creating a data set. Okay, and this particular data I'm creating for. Okay. So here I'm writing rain, and here I'm writing we train. Okay, we have one more answer. We train the machine learning machine by giving data. Okay, that's true. We okay by giving, we could say, labeled data. Okay, so here I'm writing rain. Okay, and here I'm writing plan to go out. Okay, so I have one field as rain and I have another field as plan to go out. The field of rain is true, and here the plan to go out becomes false. Then the field rain is false and the plan to go out becomes true. So here the input is rain, whether it is raining, whether it is not raining. So that is basically called as the input, and the output here is plan to go out. If it is raining, will you go out? Obviously no. If it is not raining, will you go out? Obviously yes. So this output is also known as labels, and therefore the supervised algorithm are based on input and output pair, which are already given. We have got some more answers. Decision on previous data. Okay, yes, so previous data should be labeled and we make decision on the basis of that. Sumit says this, and Yash says that first machine is trained on the basis of previous data. Okay, yeah, so most of the cases the machine will be trained on the basis of previous data only. Okay, but many a times it may happen the data might be labeled or data might not be. Okay, it may happen. Okay, but in case of supervised learning the data has to be labeled. Okay, fine, let us go back. So here you can see that we have support vector machines, linear regression, logistic regression, naives, linear discriminant analysis, decision trees, k nearest neighbor algorithm, neural networks, multi-layered perceptron. Okay, so these are few of the listed algorithms which comes under supervised approach. Okay, so let's begin with support vector machine. Okay, so support vector machine. Okay, the name itself, if somebody is listening for the first time, will say what exactly this means. What is support? What is vector? Okay, what is machine? Okay, it all looks like a mechanical terminology or civil terminology. Okay, fine, but let me help you out. Okay, in a very simple terms, what exactly is support vector machine? Okay, so support vector machine, here you can see in the diagram we have two types of data items. Okay, one type you can see that they are having different color, which are circular in shape, and another which are dark blue and they are square in shape. Okay, so two types of data you are able to see here. Okay, now as a human being it's very simple for us to basically identify, but if a machine is trying to identify, so machine requires certain parameters. Okay, so the kind of parameters machine in this case will require: what is the shape of that particular data point, what is the color of that particular element. Okay, so these are the parameters which the machine will require, and based upon these parameters it will try to understand the differences amongst them. Okay, so in case of support vector machine, okay, we try to, okay, if you look at the diagram, we try to draw a boundary. Okay, we try to draw a boundary, or you can say in very simple terms, we try to create a line. Okay, so we are trying to create a line here, and this particular line, okay, in the center, it says that whatever is on the left hand side is belonging to one category, and whatever is there on the right hand side is belonging to another category, and both the categories are different. This is the meaning of this particular, okay, present the diagram which is being depicted here. Okay, so support vector basically means what is the length of this boundary. Okay, here you can see that what is the length of this boundary. Okay, the higher, okay, the bigger the length you get. Okay, and the lines you draw like this, these are called as support vectors. Okay, so we choose the biggest margin, okay, created by these lines which are called as support vectors. So that is something we choose because that clearly identifies both of the concepts. Okay, it clearly identifies both of the concepts. Okay, fine. So once again, going to the definition. So basically, support vector machine (SVM) is a discriminative classifier. Discriminative classifier formally defined by as separating hyperplanes. Okay, and the middle line here you can see the line at present at the center, that is called as the hyperplane. So that's a plane, and that plane divides, okay, both the elements separately. Okay, and it creates a it creates a boundary. Okay, this is called as hyperplane. Okay, and okay, so we are giving the labeled training data. Okay, therefore it is called as supervised. The algorithm outputs an optimal hyperplane which categorizes the new examples. Okay, so let's basically quickly have one more understanding here. So this is our input data. Okay, so input data is there, and this input data is basically sent to this input data is right. This is the input data, and this input data is sent to our algorithm. Okay, so our algorithm basically accepts this data algorithm. Okay, and this algorithm can also be called as of now a model. Okay, so your algorithm creates ultimately your model. So once you create your algorithm, then after that, that algorithm learns from the input data, that is called as a training phase. Okay, so once it is learning from this particular input data, so this is called as training phase. Okay, fine. And after that, okay, after the algorithm is learning with the help of this input data, after that another phase is there, and that phase is called as testing phase, for which we are actually making the algorithm to learn. Okay, so next we have the testing phase. Okay, so in testing phase we are making the algorithm to test not the input data but new data. So in case of testing phase, we will provide the algorithm or the model with new data, and for that particular new data the algorithm will start giving us the output. Okay, so this is very basic level, high level understanding that how all the machine learning algorithms actually work, okay, which falls under data science. So this new data is sent to testing. Okay, and testing is performed based upon the training which has been done. Okay, so testing will be performed looking at the kind of training the algorithm has done, and based upon that we will actually get an output. Okay, we'll get an output. An example, let's say we give lot of apples as input to the algorithm to read them, and the algorithm reads the shape of the apple, size of the apple. So algorithm reads all that part, and after reading all those parts, algorithm basically takes the new data, and after taking the new data, algorithm gives the output. Okay, gives the output as whether that is apple or not. Okay, so that is the final output we get. Okay, all right, going back, so SPM we have discussed. Okay, going further, yes, so hyperplanes in this particular diagram you can again see it is nicely depicted that how the hyperplane looks like. It is not basically two-dimensional. Okay, it is more than that. Okay, this is how the hyperplane looks like. All right, now moving ahead. Okay, then we have regression algorithms. Okay, regression algorithms, these are different types of algorithms, and in regression algorithms we have something which is called as x and y. Okay, again x and y. Okay, like in this particular, okay, okay, so what happens in case of regression algorithms, let us see here. Okay, so in case of regression algorithms we won't have data like this. Okay, we won't have data like this. In case of regression algorithms we would have data something like uh, speed and time, and here we will increase the speed, and increase in speed will result in increase in speed will result in reduce in time. So let's say 25 is the speed and time is 1 hour, 10 is the speed and time is 3 hours, and let's say 15 is the speed and time is 2.5 hours. Okay, so what is happening, whatever we are changing in speed is also affecting time. Okay, so change in speed also affects time. This is basically is happening here. Also it is x and y, it is input and output. Okay, speed is input, time is output. So this also works on input output pairs. That means, which means that we have the input data as well as we have the output data, both the type of data are present, and this also is labeled. Okay, so regression algorithms, there are multiple regression algorithms. Okay, as I told that what is the basis of regression algorithm, I have already explained. Now let's basically understand. Okay, here we have independent variables, we have dependent variables. So as I said, that looking at this particular speed and time example, so the independent variable here is speed and the dependent variable here is time. Okay, so independent is speed and dependent is time. Regression line, so regression line, we draw this type of graph and we draw a line so that it basically is you can say it's a line of averages. Okay, it's a line of averages which we try to draw, and this line helps us to basically determine the further outputs. Okay, so there is a concept of regression line as well. Then there is a concept of outliers. Okay, so this is one more concept, outliers. We'll see that multicollinearity, underfitting and overfitting. Let's quickly have a look at all these things. Okay, so regression, we have two types of algorithms here. One is simple, one is multilinear regression. Okay, so two types. Simple regression algorithm, you can see here that it's basically the equation is y is equal to ax a plus bx plus u. Okay, and if it is multiple linear regression, then the equation is like y is equal to a plus, then we have multiple such b1 x1 plus b2 x2 plus b3 x3. Okay, now the biggest question is what is a, what is b. Okay, so if somebody is listening for the first time, okay, so just look at this particular slide. You can see that we discussed about there are dependent variable and there are independent variable. Okay, so two basically particular types of variables are there. So dependent variable is y. Okay, so your y is dependent variable. Dependent variable is something which is called as label also. So this is only the label. Okay, it is the label. And what we actually require is we require to identify this label for new data. For example, if somebody is running with a speed of 25 kilometers, okay, whatever, 25 units, I'll say. So if 25 is the unit of is the unit of speed of a particular individual, and the time consumed is one basically hour, in that case, if somebody else is running, okay, so if somebody else is also running with 25 speed units of speed, that person will also reach in 1 hour. Okay, so this is what basically we are trying to identify for a new person. Looking at this data, okay, I'm asking you one question. Let's say if somebody is running with a speed of 24 units per hour. Okay, so 24 units per hour is the speed. So approximately what will how much will be the time consumed by that person? Okay, quickly just share in the chat box. Okay, how much will be the time consumed to basically cover that distance? I'm asking you to make any calculations. Okay, we are not discussing we are not discussing to put that calculation here. Okay, so approximately what will be the time? Let's have it in chat. Yeah, it's 25 1 hour. So if it is 24, it should be little. There's a correlation between the speed and time, right? So there's a correlation between speed and time. So it will be little higher, less than an hour. Okay, so Ronak says less than an hour. See, what is the kind of relation we have between speed and time? The relation is if the speed is increasing, time is decreasing. I reduce the Yes, Vivek Bulani says 1.1. Okay, yes. So understand this concept. It will not take less than an hour. It will take more than an hour because we are reducing the speed. The kind of relation between them is negative. Okay, they are not directly proportional. They are inversely proportional somehow. Okay, so this y is something we need to identify. That is, time is something which is y we need to identify, and this x here, this x is your speed. This 25 is your x. Okay, but in real time, what happens in real time? Everything is not perfect. Okay, if you see in real time, everything is not perfect. So therefore, we should have certain more things. Okay, and what are those things? Here you can see that there is one population slope coefficient, there is one random error term, and there is a population intercept. Okay, so there are three more things here, okay, which will affect the output. Okay, why these three things are there? Because in real time they are not exactly proportional. Okay, there can be certain factors which might affect them. Okay, fine. But if you go for multiple regression, in that case you will have more than one inputs. Okay, let us simply have an example. Okay, so let's say if you want to go out. Okay, again one more example. Okay, what are the chances that you will go out? Okay, so is it only dependent on rain? Will it rain, then only you will go out? And if it is not raining, then you will not go out? No, it does not depend only on that. It does not depend only on that. Okay, it depends on certain more, factors. How important and urgent is your work? That is one more parameter. And where exactly do you want to go? Okay, that also a parameter. Okay, so there are certain. Do you have a raincoat or not? So if you have a raincoat or rain suit, you can easily go out. Will you drive a car or will you drive a scooter? Again, that is also a factor that will decide that whether you will go out or not. So if you see that there is only no one parameter which will decide the output, there are certain more parameters which are deciding the output. And therefore, coming back here, we may have, okay, this simple linear for some cases, but most of the cases you will have multi-linear, where you will have multiple independent variables which will actually give or decide the dependent variable. Okay, so this is how basically multiple linear regression works. Okay, a variant of regression only. Okay, yeah, what is an outlier? Okay, if you see the diagram, okay, many times what happens, let's say everybody, okay, everybody is walking towards uh, let's say to catch up fruits, mangoes, which are basically hanging on the trees. Okay, so everybody is walking towards them, and there's one guy who is basically not even bothering that whether somebody is running to behind the mangoes because it's a mango season and everybody wants to have fresh mangoes. Okay, but that person is just sitting idle. Okay, and maybe reading a book. So all of those will represent these people, this particular group, and that single person who is just sitting, not bothering about the mangoes and just reading a book, represents this particular dot which is separately lying. So he is something somewhat different from all of the people. Okay, and in this scenario, that particular person will be called as an outlier. Okay, so outlier is that particular element or that particular data point which is different from all the data points which we have. Okay, all the data points which we have. Okay, and these outliers many a times, okay, these outliers they create problems. Okay, so outlier detection is again one more algorithm, okay, which needs to be applied so that we can eliminate the outliers. Okay, then another part, multicollinearity. Okay, this is another part. Multicollinearity means, okay, here you can say that there is a yellow box and there is a red box. Okay, and they are overlapping, so there is a section here which is overlapping between them. Okay, so this section basically, okay, which is overlapping here, this basically denotes the multicollinearity. This I will explain you what does this mean. Okay, let's say speed and time. Speed is the input and time is the output. Okay, simple, right? Speed is the input and time is the output. Okay, but what is happening? Okay, we have one more column here. Okay, let's say, yeah, so we have, yes, so you can see one more column here, and that column is distance. Okay, so that column is distance. So you can clearly understand that if speed will increase, time will decrease, but distance will increase. So if speed is going to increase, the distance is also going to increase, but time is going to be reduced. So we have two parameters, speed and distance, and the output parameter is time, but the two parameters themselves are related to each other. They are dependent, and this is what is an example of multicollinearity. Okay, so we have one output variable, but we have the number of input variables and they are correlated between them. Okay, so that is called as multicollinearity in a data set. Let's move ahead. Okay, so there is a concept of fitting a line of regression. Okay, so here you can see that this is called as fitting a line of regression. Okay, so in regression we normally try to fit the line so that we are able to we are able to divide the data into proper category or proper class. Okay, so that is that is something we actually want. Okay, that we can determine the exact value. So here basically we want appropriate fitting. The center figure shows appropriate fitting, and the figure which is on the right hand side and which is on the left hand side, they are not the appropriate. This is underfitting. Lot of wrong classifications are there. This is overfitting because this will only give correct output for the data which is already present. It will not give correct output for any other data set. Okay, fine, let's move ahead. Okay, so yeah, linear regression we have discussed. Okay, so this is a pictorial representation of linear regression. You can see that. Okay, we draw a graph and we plot, and then we try to draw a regression line which basically shows that what is the relation between the data points, okay, amongst them. There is one more type of regression which is called as logistic regression. Okay, logistic regression, it just works on concepts like true, false, alive or dead, healthy or sick, pass or fail, win or lose. Okay, so the output is binary. Okay, the output is binary. So this is basically logistic regression. So in the diagram you can see that the logistic regression basically divides the data into two parts. Okay, so the line of regression is the decision boundary which tells that whatever is up is red and whatever is below is blue. So whatever new data will come, that also will be either red or blue. Okay, it will not have any other different type. Then we have probabilistic learnings. Okay, so in probabilistic learning this works on the concept of probability. I'm not going to get into the details of probability much. Okay, here in the slide you can see that in case of probability what happens. In case of probability, in this example you see that we have total two events. Either it will be head or it will be tail. Okay, and the probability of getting head is 1 by 2, the probability of getting tail is 1 by 2. Okay, so both have equal probabilities here. Now if we are tossing two coins, in this case we have probability one getting HH, HT, TH, TT. So four possible outcomes are here, but in this case HH and TT are very much different. So 1 by 4 is the probability. TH and HT are same because one H and one T, the sequence does not matter. So therefore it is 2 by 4. Okay, so this is the basically count. Fine. This is the probability. Why probability I have introduced? Because in probability we have the popular algorithm naive Bayes. Okay, so naive Bayes is the algorithm which is very popular in case of probabilistic approach. In probability again we have independent dependent events. Okay, independent events basically means yes, so here you can see an example in independent event that yes, in case of independent events, we toss a coin. Okay, and once again we toss a coin. Once you get head as an output, the head part does not get removed from the coin. It remains there itself. Okay, the head part remains there itself, so it does not go out somewhere. Okay, so therefore basically this particular thing is called as independent event. And dependent means that if you are having, okay, here you can see if you are having like five balls, two are blue and three are red. In this case, once you pick up one ball, then basically in the second event you don't have five balls but now you have four balls. Okay, so in this case basically the probability always changes with respect to the total number of elements you have. Okay, next so therefore if you want basically, yeah, so if you want you can basically keep the taken out ball once again to make it independent. Okay, but if you have taken out a ball and it is not kept back again in the bag, it becomes dependent. Okay, fine. So now let us discuss the concept of conditional probability. Okay, because this will take you to the concept of naive bias. Okay, so here you can see that the of an event probability of an event provided some event has already taken place. This is the concept of conditional probability. And what will happen here? Here in this case, you can see that we have certain numbers. Okay, we have certain numbers, and we want value will be less than 4. Okay, so we are taking example of rolling a dice, and once we roll a dice, and in that case we want that the value should be less than 4. Okay, so in case of rolling a dice, value will be greater than 4, only 5 and 6, and less than 4, 1 2 3. Okay, second is, it is given that it is an odd number. So if it is an odd number, we will write odd numbers also here. So 1 3 5 are odd numbers, and 2 3 2 4 6 are even numbers. Okay, so two conditions: less than 4, okay, this is less than 4, and odd, this is odd. And let us now merge them. Okay, so let us find the intersection of them. Okay, so here you can see the intersection we are able to find. Intersection is 1 and 3 is the intersection. Okay, so 1 and 3 have the chances, this is the conditional probability, okay, that what is the value, what is the probability that the value will be less than 4? So 2 is the chance. Okay, so two chances are there out of all the events that the value will be less than 4, given that all the numbers are odd. Okay, because 2 will be eliminated, 2 is not odd, it is already given that all numbers are odd. Fine. So this is basically concept of conditional probability, and on the basis of conditional probability, we have an algorithm which is called as naive Bayes algorithm, which works. And here you can see the formula of conditional probability. Okay, it is read as that probability of A such that B has already occurred, and here we find the intersection of A and B and divide by probability of B. Okay, so this is what is the formula. And Bayes theorem, it basically is derived from this formula only. Okay, this tells, okay, the purpose of Bayes theorem is that how often A happens given that B happens. Okay, so how often A happens given that B happens. So what is the practical use of Bayes theorem? The practical use of Bayes theorem is that, let's say, whenever there are um, clouds in the sky, okay, how often you are able to see the rainbow. Okay, so this is basically a problem of which can be solved by Bayes theorem. Okay, so how often do you see a rainbow whenever it is cloudy? Okay, so that's basically an application which comes under Bayes theorem. Okay, fine. So I'm not getting into the detail of all these values. I've told what is the importance of Bayes theorem. Let us basically come to the naive Bayes classifier. Okay, so this is basically an approach which help us to classify, or basically it is again one concept under supervised algorithms. Naive Bayes classifier, it works on the basis of Bayesian algorithm, or you can say the your conditional probability. That is the building block of naive Bayes classifier. All right, then there are dimensionality reduction techniques. Okay, so this is again one important part. Can somebody tell in the chat box what is a dimension? What exactly is meant to be a dimension? What is the meaning of dimension? Yeah, quickly, can somebody tell me in the chat box? So we will discuss about dimensionality reduction techniques. Okay, so we are reducing the dimensions. Okay, so for that I just need some comments in the chat box. What exactly is the meaning of dimension? Do you think that dimension or uh, yeah, please write. Dimension means size. Okay, okay. Any other answers? Any other answers we have? Vivek says it means size. Okay, size reduction. Okay, so let me comment on size. Yes, so we can say that dimension is size. Yes, so I'll ask size of what? Okay, so in any basically algorithm, okay, we have number of we have data to be inputted for training purpose, and that data is having number of columns. Okay, and these number of columns are also known as dimensions. Okay, so these number of columns are also known as dimensions. Yeah, Yash says attributes. Yes, so you can say these are the parameters, or these are the columns, these are the attributes. So these only basically constitute the dimension. Okay, So in dimensionality reduction techniques, what is the use of dimensionality reduction techniques? The use is that, let's say we have 100 parameters to be analyzed in order to bring in some output. Okay, so how many do we have? We have 100 parameters. Okay, so in order to calculate, make the calculation for 100 parameters, and if you have a large amount of data, it becomes very difficult for the algorithm and the computational resources to perform the execution. Okay, so what you can do is in this case that you can reduce the dimensions. That means you can reduce the number of attributes or number of parameters, and you can keep the relevant ones. You can remove all other ones. Okay, so if you are keeping the relevant ones, that is called as dimensionality reduction technique. Okay, so LDA is one basically dimensionality reduction technique. There is another which is called as PCA, principal component analysis. Okay, so it comes under unsupervised approach. So yeah, so let's quickly basically go through this. So LDA, it is dimensionality reduction technique. As the name implies, dimensionality reduction techniques reduce the number of dimensions, that is variables in the data set, while retaining as much as information as possible. Okay, this is the purpose of dimensionality. So linear discriminant analysis, here you can see that this is the data set, and if we are trying to basically reduce it to a single okay, here you can see in the diagram, if we want to because here x and y coordinates are there, and we are trying to denote everything in the x, a single in single dimension. In that case, here you see that this kind of data we would end up with us. Okay, which will actually lose lot of information. Okay, but in case of linear discriminant data analysis, okay, so this is how we should do. Okay, this is the approach how we should basically don't lose the information, as well as we should be able to reduce the multiple dimensions and reduce them into let's say whatever number of classes possible. Okay, so this is linear discriminant analysis. Okay, another algorithm here, supervised approaches, decision tree. Decision tree is basically, here in the diagram you can see decision tree works on the basis of questions. Okay, you can see that you can have questions. For example, leaves, if you see, so there are some bluish leaves and there are some green leaves. Okay, so the question is, if it is blue, okay, take it to the left hand side. If it is green, take it to the right hand side. Okay, so every basically step you have to ask question, and based upon that question you have to decide what to do. Okay, here also you have to decide, okay, what is the question, based upon that you make this choice or you make this choice, and further. Okay, so decision tree is basically again for making predictions. Okay, so at each node there has to be some question, okay, which will decide that in which branch will you go. So decision tree, they have nodes, edges, branches, and leaf nodes. So these are the things which basically create. This is one example of decision tree. Okay, so is the person fit? So the question is age, less than 30, yes, no. Okay, if it is yes, eats a lot of pizzas, yes, no, yes. Okay, then he's unfit. So every basically stage you have questions. Okay, fine, let's move ahead. Yeah, so we have two types, classification and regression, which we have already discussed. Okay, so this is supervised approach where we have classification and regression. Now moving ahead to one more type of algorithm, which is called as k nearest neighbor algorithm. Okay, so this is also supervised, and why it is named as neighbor, because in your neighborhood you always know who is your neighbor. Okay, if you don't know that who is your neighbor, that means that he is not your you yourself are not treating him as a neighbor. Neighbors are basically treated to know are meant to know each other and support each other, help each other. Okay, therefore this particular algorithm is named as k nearest neighbor algorithm. Okay, this also works on labeled data, supervised data. We already have been given the labels, the outputs. Okay, whatever new input comes in, we just compare it with all the other inputs, and we give them a particular class, that which class it belongs to. Okay, so this is nearest neighbor algorithm. Okay, so here you can see that this particular question mark, okay, this particular question mark, it is nearer to the green triangle and red particular star. Okay, but other nearest are these three stars are nearest. Okay, so here you see 3, and here also you see 3. Yeah. So in this case, if you see that where should we classify it? Okay. So wherever it will find, this question mark will find more number of neighbors. Okay, based upon its features or the distances in the features. it will basically get into that particular you can say class. Okay, this is k nearest neighbor. ANN artificial neural networks. This is another type of algorithmic structures where we have multiple algorithms. So it basically works on the basis of human neurons. Let's basically have a look at this particular diagram. Okay, so how this diagram is explained, that whatever we touch, there are neurons which basically sense it, and immediately within a fraction of seconds they send it to the brain, and then brain is able to take an action. If you touch a hot plate, immediately your hand will move back. Why? Because whatever has happened uh, has been registered into the brain so quickly. Okay, and brain was able to give the signal of output as well. So quick decisions, okay, solutions should be made. That is the basically concept of neural networks. Inside neural networks we have multiple algorithms. Okay, this is the simplest architecture of neural network. Let's basically have one of the another simplest architecture. Here you can see you have input data, and along with your input data you have some logical layer which is called as your neurons. So these are your neurons. Okay, and here you have written a function. Don't Let's not make it very complex. You simply write a function inside these nodes, and your data is getting input to the function, and your function is giving some output. Okay, so this is simplest structure of neural network. Let us move ahead, and let's see the next one, RBF, that is called as radial basis function neural network. You can see in the diagram that how this function is working. Okay, so this function is working on the basis of considering the distance of point with respect to the center. Okay, so consider the distance of a point with respect to center, and here you can see it is doing the same thing. Okay, consider the distance of the points with respect to center. Okay, and it has got two layers. First, where features are combined with radial basis function in the inner layer, and second one is the output of these features are taken into consideration. Okay, while okay, so here you can see the difference. The features are combined with radial basis function. Okay, so in the first one, if you see, what is the difference? Input is directly given to the function, and the function is giving the output. Here the radial basis function, it is combined with the input, and then basically the output features are taken into consideration while computing some same output in next time step, which is basically a memory. Okay, so what does this mean? This means that it will save the outputs for next time, so that next time basically better experience can be given. Okay, fine. Coherent self-organizing neural network. So these self-organizing neural networks, the objective is to basically input vectors of arbitrary dimensions to discrete map comprising of neurons. Okay, what does this mean? That here basically we get the data, and from the data, if you look at the diagram, what is happening? Okay, so what happens here? Yes, so here we have to basically train the algorithm, or basically you can say here the algorithm itself is map. So we basically train the map. Okay, train the map so that it can organize itself. Okay, so here we can have one or two dimensions, okay, depending upon the use case, and the map itself learns from the data and itself basically organizes itself. This is one type of neural network which is called as coherent self-organizing neural network. Okay, next is recurrent RNN. Okay, recurrent neural network. This recurrent neural network, okay, this has got speciality. The speciality is that it has got long short term memory. Okay, so long short term memory means, one example, like you make use in mobile phones, you type something and it gives you recommendation. Okay, so it gives you recommendation. Why? Because it has previously noted that if you write hello and after that you always write how are you, so as soon as you write hello, it will give you how are you. Okay, so that is basically long short term memory. Okay, so it will have a bigger memory, but that memory will be for short term. Okay, so but it will store the data so that it can basically produce the output. So this is the special feature in case of RNN, recurrent neural network. Another type is convolutional neural network. Okay, so these are similar to feed forward neural network. Feed forward is the basic neural network which we had discussed. Okay, but the difference is it has got learnable weights. Learnable weights means the input which you are getting. Okay, the input which you are getting, that input will be having learnable weights. This is the importance in case of convolutional neural network. Okay, inputs will be having learnable weights, as well as it will be having biases. Okay, so this is another type of neural network itself. Modular neural network. So this modular neural network is basically a collection of multiple neural networks which we have discussed. It may be feed forward, it may be convolutional, it may be it may be recurrent neural network. Okay, so it's a mixture of multiple neural network, that is called as modular neural network. Okay, so these are the algorithms which come under supervised. But now if we talk about unsupervised algorithms, okay, if we talk about unsupervised algorithms, in this case we have clustering approaches, we have anomaly detection. Neural networks again come under unsupervised as well. Okay, then we have a concept of expectation minimization, we have methods of moments, we have blind signal separation. Okay, so let's cover a few of them, okay, in the limited time. K-means is one of the simplest algorithm, or the first algorithm you may learn in unsupervised learning. K-means is a distance-based learning algorithm. You can see in the diagram, okay, I'll show you it again. The centers, these X points, they basically mention, they are represented as the centers, and you can see that the centers are moving towards the actual centers. Okay, so initially you don't know what are the centers and how to basically group the elements. You have to group the elements into basically three or four different categories. Okay, so you need to know that how many categories do you need to have. Okay, so let's say three categories you need to have. So initially you are not knowing what is the category, and then slowly in each iteration you are able to identify the new centers and the distance of the rest of the elements with the new centers, and on the basis of distance you are able to make proper grouping or clustering of the data. Moving ahead, we have a priori algorithm. So a priori algorithm is basically every day this algorithm is being used. Okay, a priori algorithm. So what is the use of everyday use of this particular algorithm? The everyday use is that you can see that a lady is selling some vegetables. So lady keeps the potatoes, and lady keeps the onion together. Okay, why lady keeps them together? Because lady knows that potatoes and onions are mostly bought together. If somebody is buying potato, that person may buy onion as well. Okay, so this is called as association rule algorithm as well, or a priori algorithm. So there are association rules one item and another item is having. Okay, based upon that this a priori algorithm works. Let's move ahead. Okay, there are concept in case of a priori. There are support, confidence, and lift concepts, which I can give you in separate video or separate presentation. Okay, let's move ahead. We have a concept of mixture models. Okay, so this is another type of algorithms we have. Mixture model, it works on the basis of probability. Okay, so therefore it is called as probabilistic model. And what is the use of mixture model? It represents the presence of subpopulations within overall populations. Okay, so understand what is the concept of mixture models. It basically identifies or represents the presence of subpopulations within overall populations without requiring data that an observed data set should identify the. Okay, so again, therefore it is called as unsupervised because it does not requires label data. Okay, so here it has basically clustered. A subpopulation is cluster 1, another subpopulation is cluster 2, another subpopulation is cluster 3. So three clusters here we have. Okay, so three subpopulations among the whole populations here we have. Okay, this is a mixture model algorithm. Then we have db scan algorithm. Okay, so db scan algorithm is basically density based clustering algorithm. Okay, so density based clustering algorithm, how does this work? It has got two main parameters. Okay, as you can see that density, so how will it work? It will have some relation with density, right? Okay, so here you can see that the minimum number of, it has got two important parameters. One is called as min PTS, that is minimum points. Another is called as EPS, that is epsilon. Okay, so the min PTS, that is minimum points. This is minimum number of points or threshold clustered together for a region to be considered dense. Okay, so what does this means? That okay, it is working on the basis of density. Density means let's say we have three people together and we have 10 people together. So do we call 3 people together as a dense area or 10 people together as a dense area? So let's say our threshold says that if it is 8 or more, it will become a dense area. So where there are 3 people, that will not be called as a dense area, but where there are 8 people or more people, that will be called as dense area. Okay, so that is one parameter this DB scan algorithm works. Another is epsilon. Okay, that is a distance measure that will be used to locate the points in the neighborhood of any point. Okay, so this is the distance. Okay, because if you see here in the diagram, okay, so we have one point and this point has got some distance. Okay, this point has got some distance, even these points have some distance. Okay, so how much distance to be, okay, considered in order to basically choose some neighbor. Okay, that is, these are the two parameters which DB scan works upon. Okay, another algorithm we have is optics algorithm. Okay, optics, the full form is ordering points to identify the clustering structure. Okay, once again, ordering points to identify the clustering structure. Okay, so again, this is an algorithm for finding density based cluster. Okay, so it is similar to the previous one, but it adds two more components. Okay, what are the two more components? One component is core distance. Okay, so core distance is the minimum value of the radius required to classify a given point as core point. Okay, so we have to select a core point. In the previous diagram we have seen that some core point has to be selected. Okay, so for that particular core point to be selected, we need to have a minimum value of radius. Okay, we need to have minimum value of radius. Okay, so that so then only that core point will be. So you can see that this is an optimization on DB scan. Okay, and reachability distance, so this is defined with respect to another data point. Okay, reachability distance between point P and point Q is the maximum of the core distance of P and the Euclidean distance. Okay, so this is another parameter, reachability distance. So these two parameters are added in order to make the optimized DB scan algorithm called as optics algorithm. Okay, so that's all for today. Okay, these are the set of algorithms which we wanted to discuss with you. I would request to write us on comment. Okay, this was the first YouTube live we have done, and I would like to thank everybody for your active participation. And we would really like to get your feedback so that we can come up with maybe some more modules of algorithms or machine learning concepts or data science concepts or data structures. So whatever you want in relation to big data analytics, okay, you can write in the comment box or you can directly mail us. Okay, we will try to produce free content for you. Okay, and thanks for watching once again. Please do like, subscribe and share. That is a request I would like to make, and help us to create more such good videos for you. Thank you once again. So I would like to thank all the colleges who basically all the students and colleges who participated, even the working professionals who participated. I would like to thank everybody.